Just to show detailed reasoning, I'm actually going to show you two different ways to do this question. Because my initial thoughts when I did this question, which is not what the mark scheme originally thinks, is just to square everything out. Whenever I see a square root, I want to sort of get rid of it. So square the left-hand side and square the right-hand side. Nothing wrong with doing that. You just got to be careful. Sometimes you get extra solutions. Like we could get a negative x solution in theory, and that can't actually be true because we can't take the square root of a negative to get a real number. So just be careful if you ever square an equation. I'm not going to get into any more detail than that. Now this is a double bracket, so it's actually 3x plus 1 times 3x plus 1, so I'm going to get 9x squared when I do this one. Then I'm going to get plus 3x and plus 3x, so plus 6x, and then I'm going to get a plus 1. And then when you have a bracket like this and you're squaring, you actually square the 4 and you square the root x. So I've managed to turn this into a quadratic. 9x squared minus 10x plus 1 equals 0. Try and factorize it. We're asked for detailed reasoning. We've got a positive here, but we've got a negative 10x. So they're going to have to both be negative here, and they've got to both be 1 for this to work, and it does work. Which gives us x. 9x is 1, so x is 1 over 9, or x equals 1. And these are absolutely valid solutions. One thing you could do if you had time is just check them. So if we put x equals 1 in, the left-hand side is 4, and the right-hand side is 4. If you put 1 over 9 in, it's a little bit trickier, but we're going to have 3 over 9, which is 1/3. We're going to get 1 plus 1/3, 4 over 3. And then here, when you square root 1 over 9, you get a third, so this would also be 4 over 3. Method 2 is to actually identify this as a hidden quadratic. So I'm going to rewrite it as 3x plus 1 minus, wait, I put it in the wrong order, 3x minus 4 root x plus 1 equals 0. And then you've got two options. You can either write it as a quadratic in root x, or you could do a substitution, let u equal square root of x. And it's a bit easier to see. We're going to get 3u squared minus 4u plus 1 equals 0. I personally think that's harder to see, but maybe, maybe this is how you thought about it. And then a different quadratic to factorize, it will still factorize actually. It's got to be 3u and u. Again, it's got to be minus 1 and minus 1. And then we get u is equal to a third or 1. You could factorize directly in terms of root x. That's an alternative. In any case, we're going to put it back in terms of root x now. Root x is a third or 1, and we're going to have to square it. Now, if you've got a negative here, we would have rejected it, and we would have rejected x as negative here. So it's all good. Just square it. Make sure there's no problems with squaring it. 1 over 9 or 1, we get the same answer. So two approaches, same answer. Nice question.